Good afternoon, class. Today we're going to be looking at lines. Some of y'all may remember this if you took the developmental math course, or you may remember it from high school. I know my class yesterday, some of the students said it was familiar to them, a lot easier than cut points or solving square root equations at least. We graphed lines the last time using the wonderful Pearson MyLab graphing tool, but for some reason, I don't think we assigned any problems using the graphing tool today. We used the old-fashioned multiple choice when it came time to draw lines. But recall the last time I said that a line is any equation that can be written in the form ax plus by is equal to c. I said that there are no exponents on the variables. Realize x and y are the variables, a, b, c are numbers. And you don't have any square roots of x. You don't have a y, an absolute value of y. There are no powers or operations being performed on the exponentiation or operations being performed on those variables. If this is said to be in standard form for the equation of a line. Realize if a were 0 times x, you wouldn't have an x. Or if b were 0 times y, you wouldn't have a y. Well, you have to have at least an x or a y, but you may only have one of those variables. If your equation contains both an x and a y, you are looking at a slanted line. Okay. That's not a good purple. That isn't a good purple. Take that purple pen away. So, now, if your equation contains only a single variable, we're looking at two special types of lines. If your equation can be written in the form x equals a number. If you can get x by itself on one side and a number by itself on the other side, there's no y, the b value is 0, then what you have there is a vertical line. The line is vertical, passing through the x-axis at the number n. If your equation contains only an x and no y, the graph is vertical. That variable there says what axis the line passes through. This number here says what number it passes through on the x-axis. And just a reminder, a vertical line is up and down. That's what I mean by vertical. If your equation contains only a y, if it can be written in the form y equals a number, instead of a vertical line, you have a horizontal line. So the line is horizontal, and it passes through the y-axis at the number n. This might be exactly the opposite of what you're thinking, because the x-axis is horizontal, but x equals a number is vertical. Why? It's passing through the x-axis. This says what axis the line passes through. This number is the number where it passes through. Likewise, the line's passing through the y-axis, so it's horizontal, passing through the y-axis at that number. So let's see. So the line passes through the y-axis. Well, it's got to be a horizontal line, not a vertical. That's not a very good horizontal line. Oh, well, it's a little slanted. I'm one of those engineers at Flatiron designing our bridge, right? Oh, that's good enough. That horizontal line's good enough.
Tim, that's been recorded. Go ahead.
Let's
Some terminology that we might have introduced the last time.
I know I did. Y'all remember I said the X-Intercept is the point where the graph passes through the X-axis. I'll say point where graph intersects the X-axis, and the Y-intercept, that's the point where the graph intersects the Y-axis. I'll just say where graph intersects the Y-axis.
And I think we're ready to jump in and do a few problems.
I want to remind you of something else. I made a comment the last time. If we're looking at a point on the X-axis here, let's see. Yeah, okay. Let me draw it. I'm going to freehand a little graph. Move it up. Okay. Here's a line. So there's the X-intercept. This is the Y-intercept. For the X-intercept, where the graph is passing through the X-axis, what is the Y-coordinate at this point? If a point is on the X-axis, we know something about the Y-coordinate. What is it? That's correct. It has to be 0. So for the X-intercept, make a note, the Y value is equal to 0. Applying that same logic to the Y-intercept, we don't want to move left, right. What do we know has to be true about this X-intercept? This X value. It has to be 0. So do y'all remember my mentioning that? We even graph lines. We plugged in 0 for X and then we plugged in 0 for Y. We were finding the intercepts. Okay. So with that in mind,
problem
number 1. Let me write it down. Oh, I don't think I need to write. Oh,
okay. Number 1, I don't think we need to write it down. Let's see. I'm going to try to pop this out to make it a little bit bigger. The instructions said, I actually should have looked at that first. Find the coordinates of the Y-intercept and the X-intercept. Okay, so, right there. This is the Y-intercept. Y'all see where my cursor is? What's that ordered pair there? 0. I'm thinking it's 4. Is it 0, 4? But yes,
0,
0, 4. Well, I'll wait.
I'll write it down.
Write it. No, I'm going to type it in.
Oh.
Parentheses 0, comma 4, close parentheses. Remember one day a student emailed me something and said, oh, they got the answer wrong and they know it was right. Can y'all tell what I did wrong here? It's an O, not a 0. Okay? It might look like a 0, but I typed a capital O. In my math lab, never type anything, any capital letters. So, that way you won't wind up using an I when you should use an L, or an O when you should use a 0. Now what about the X-intercept? What's that ordered pair right there? 2, 0? The problem 1 doesn't really have any, scribble work to do. You know what I mean? Some problems, you got to write it out and scribble, scribble, scribble to get the answer. Not here. Now, let's see problem number 2.
Find the intercepts and graph the line. Oh, you see, given it to us in multiple choice. I like the little graphing tools, but this is quicker. So, what is it? X minus 2y equals 2.
it also gives you an idea of what Pearson, MyLab. Well, wait. When it first was invented, it was Addison Wesley, right?
I think so.
I think it was, and then
Switch
became
over.
Pearson. Back in the day, everything was multiple choice. So it says find the intercepts. So to find the intercepts, you've got to plug in zeros.
So I'm going to make a little table. We're going to have to plug in 0 for x to find y. And we'll have to plug in 0 for y to find x. Let's plug in 0 for x first. Here we go. Plugging in 0 for x. We get 0 minus 2 times y. So that just becomes a negative 2y is equal to 2. What does y equal in this case?
What do we do to isolate the y?
Divide by
both
negative
sides by
2.
negative 2. And what are we getting for y?
Okay, now we'll plug in 0 for y.
I think that's going to work out a little bit easier.
Oh, it is. We have x minus 2 times 0. It's just 0. So all we get is, on the left side is x, and on the right 2. It's already solved. So we have a X-intercept at the order pair 2, 0. We have a Y-intercept at the order pair 0, negative 1. Let's just freehand ourselves a little graph here. Oh, yeah.
We have graph paper, but it doesn't have to be real exact.
I suppose that a teacher probably told those bridge engineers the same thing. And that's what they used when they were designing our little harbor bridge.
Tim,
I've got to stop saying that.
I know that.
Okay. Well, the original company's out of business. I don't think I can slander or what is it? Slander when I say it in, right? So 0, negative 1, left, right, 0, down 1. Okay, where's 2, 0 located? You tell me how to go there.
Is it going to move right or left?
Right 2, up 0, okay.
Oh, just A, B, C, or D. Which one is it?
I think you can tell just from the intercepts. A, B, C, or D.
It is A, and if you want me to make the graph a little...
Pop it out.
Oh, look at this. I was about to say no, but look at how are they incrementing this? 2. Yeah, 2, 4, 6, 8, 10. So this would be 2, 0, and this is a negative 1 right there. But each little mark is 2.
I think you could tell just by looking at the intercepts.
Yeah.
0, negative 1, and 2, 0. So click it and see if we're right. We better be.
Okay.
Oh, number 3.
You see, how does problem 3 differ from problem number 2? Well, there's only one variable. Remember, on problem...
Switch it over before they see all that.
Okay, but here, if there's x's and y's, you're going to have a slanted line. If there's only one variable, it's either vertical or horizontal. Okay, so how do we graph? It didn't say anything about intercepts, just how do you graph x equals 3?
Draw yourself a XY grid. Okay, then. Okay.
When there's just one variable.
The variable that appears tells you which axis the line is passing through. This line is passing through the x-axis at the number 3. So you go to the x-axis at the number 3 and extend the mark that's there. You see we have that little vertical tick mark? If there's an x and no y, you expect your graph to be vertical. Going back to what I stated over here. If your equation can be written in the form x equals a number, you expect the graph to be vertical, passing through the x-axis at that number on the right-hand side. So it's a vertical line passing through the x-axis at 3. And let's discuss why that's the case. Why does x equal 3 describe this line here? Someone give me the ordered pair of representation for that specific point there.
What's this ordered pair?
3, 1, I agree. What about this point right there? What would that be? 3, negative 2. And what about way up here? 3, 4. The important thing here is every x value is what? Every x value is 3.
This vertical line passing through 3 has nothing but x values of 3. So let's see which one it is. Let me see. Oh, I'm thinking it's A.
I
You want me to pop out the others so you can, you see, no. This one has y values of 3. So it's not that one. Not this one either. Here the y values are negative 3. And what's wrong about this one? Negative 3. Yeah. So it is A. Well, that one had x's and no y's. I bet the next one will have y's and no x's.
Okay, by plus 4. Okay. Okay, let's switch over. Okay, y plus 5 equals 0. We know if there's a y and no x, the graph is going to be horizontal, but to determine where it passes through that y-axis, we need the equation in the form y equals a number. So we're going to have to modify this equation. We need y by itself on one side. What do you think I'm going to do? Subtract 5 to give me y equals negative 5. And then, drawing our little XY grid.
Well, I think you better be putting 5 up.
I'll put 5 there. Oh, goodness. That's a mighty wavy set of lines, isn't it? But for what we're doing, it's good enough. If you're going to be building bridges or designing runways one day, don't think to yourself as you're making those designs, that's good enough. Okay, this says, we're looking at the horizontal line passing through the y-axis at negative 5. 1, 2, negative 1, 2, 3, negative 4, negative 5. We draw the horizontal line. There it is. So it's a horizontal line passing through the y-axis at negative 5.
It passes through this axis at this number. It has to be horizontal then. It can't be vertical.
Every y-coordinate on this purple line I just drew. What is? We know every y value on this line. What is it? Negative 5. No matter where I label the point, I know that y value will always be negative 5.
Well, let's see. Oh, let's see. I'm thinking it's not A for a change. It's not B. Is it C? Yeah,
I think it is.
Well, I'm glad to hear you saying I think it is. when you know it is. You're sounding like me more and more.
Oh, I don't think so.
Okay. Well, now.
You want to take over here now?
Oh. Okay. A new word, not really, but not new to the world of math, but
it may not even be new to you if you've seen lines before, but it's a new word we haven't used in this class this semester.
The slope of a graph measures, of a line. Slope measures the steepness or the slant.
I like your word steepness better.
Of a line.
Yesterday I said it measures the slant of a line. That's what I've always said. But Tony,
keep on going.
Tony said he liked the word steepness, and I like it too.
What letter do you think is used to denote slope? Of course, the lowercase m is what we use to denote slope.
I think you said once. Well, I remember Janet Clark, my first algebra teacher, saying that we use an m because it stands for measure. The slope is a measure of the whatever. But in reality, an important application of slopes in economics is marginals. And that m that they use to denote it is really paying some homage to...
It stands for margin.
Yeah, it stands for marginal.
But in general, if you have a line that's slanting upward to the right, then the slope is positive. If a line slants downward to the right, the formal word for that would be decreasing. Increasing means rising from left to right. Decreasing means falling from left to right. Oh, no. Oh, well, there's arrows on both of them, okay? But just looking at the shape, if it looks like it's rising when you go from left to right, then it has a positive slope. Falling, negative slope. Then a vertical line has a slope that's undefined. The slope is undefined. And we've seen that word undefined this semester in regards to fractions. And when is a fraction undefined? When the bottom number is 0. It's going to have something to do with that. And a horizontal line is not steep at all. Its slope is 0.
Oh, I want to say something. I don't think I said this yesterday, but I think I'll say it today. Another thing, or another interesting fact about slopes, is the slope tells you how the y value changes when you increase the x value by 1. Slope tells you how the y value changes when you increase the x value by 1 unit. So here, as I change on a horizontal line, if I start changing my x values, by how much do we expect the y value to change? Every y value on this horizontal line, is it changing? Say no, horizontal lines have the same y value. So you can change those x values all you want. The y value will never increase or decrease. It'll stay the same. Now with a vertical line, when you start changing the x values on that line, How is the y value changing? I claim that's meaningless. Think back to this vertical line here. If you're looking at a vertical line, can you change the x values? No, the x values aren't changing. So to ask yourself, how is the y value changing when you change the x value? On a vertical line, you're not changing those x values. That's one way of understanding why the slope is undefined.
You want to get the geometric definition of
Here's
slope?
the geometric definition of slope. Slope equals, and that's one thing. I still use cursive for my letter M like money. I use 3 little humps there to make sure you can tell that it's an M.
I use cursive when I sign my name.
Well, maybe you're just a little jealous. I've won all those penmanship awards in elementary school. From 2nd grade to 5th grade, I always won penmanship awards. Doesn't do to peak early, you know. If you think about it.
Okay. One person's laughing at it.
It's a joke.
Well, you did
but I did win those penmanship awards. I had the most perfect cursive writing, but nowadays, what's that worth?
Nothing.
Okay.
Slope is rise over run.
Oh, we're being recorded. I forgot that. Okay. The slope is rise over run. I know that, Tony. We're just help me remember what I was supposed to say.
Why don't you write that? I like it.
So, I like the way you wrote that, Tony. So, by the rise, we mean the up or down movement. So, how is it up or down movement?
And we'll do an example illustrating it.
You see, I would always say vertical movement over horizontal movement, but I think that up or down movement is good for rise, and the run, that's left or right.
Right or left. Go positive.
Oh, okay. Right or left.
For no reason.
To me, I always say vertical movement over horizontal movement.
And to demonstrate what the heck we mean by that,
it's not that involved, so don't panic.
It's one of those problems you can sort of do without actually writing anything down.
Okay, what are those points? I want something to look at. Y'all don't need to write this down, but I'm going to just to have something to point at.
See, we have a slanted line here. Let me blow it up a little.
1, 2, 3, 4. So passes through the x-axis here. And the y-axis, is it there? Okay,
so it's drawing the line, but you don't have graph paper, so...
I know, but still.
You're going to start at one of these dots and move to the other. Generally, I start at the lowest dot, using the words up, down, right, left. How do I go from this dot to this dot?
Switch to the green thing.
Okay.
So we're going to go...
So we can see your beautiful
slope is equal to rise over run. And I generally start at the lower dot and try to work my way to the upper dot. Is that what you do?
That's what I said.
Oh, okay. Well, we start here. We're starting at the lower dot. How many units up or down? First of all, would I have to go up or down to get on the same level as this second dot there? Up, so I'm going to be, my rise will be in the positive direction. How many units do I have to move up? 1, 2. So I say we have a rise of positive 2. So I'm positioned right there at that little X.
Now are we moving left or right?
We're going to move, okay, to get to the actual point, we're moving in the negative direction, so to the left. And how many units? 5. So our slope, positive 2 divided by negative 5, our slope is negative 2/5. Any questions there?
So always start on the bottom?
It doesn't matter.
That's a good question.
You know, I'm going to do the classic new teacher mistake. I'm now going to work it a different way, okay?
Suppose you started at the top point.
And
you wouldn't be
the
moving up. You'd be moving down.
Down, and so the rise would be in the negative direction. How many units? 2 over Now we're going to have to move left, right. Are we moving in the positive direction or the negative direction? We're positioned here. Positive direction, how many units? Negative 2 divided by positive 5 is still negative 2/5. So it doesn't really matter. Start at one point, use rise over run to get to the other point.
Okay, let me punch in a negative 2/5. Negative 2 over 5. Now I should ask this.
Yeah.
Under what circumstances would we have chosen this? The slope is undefined. If it had been what type of line? A vertical line. Okay?
That's correct.
Remember, vertical lines are the ones where the slope is undefined. Okay. Oh, let me check this. Okay.
Now, it's fine drawing a graph and counting rise over run, but you know, in mathematics, we always like a formula, so we don't have to resort to always graphing. So, remember we had the distance and midpoint formula the last time. We have another formula here. Let's switch it over.
This is called the slope. Oh, it says find the slope. Here's the slope formula.
Oh, by the way, how many of y'all remember that phrase, rise over run?
Have y'all heard
Some
that
of y'all have heard
somewhere?
that, right? Okay. The slope formula. Okay, first of all, you have to be given 2 points. You have to know 2 points on the line in order to use the slope formula. And I'm going to use the same ordered pairs I used with the distance and the midpoint formulas. X sub 1, Y sub 1, and X sub 2, Y sub 2. Then the slope of the line passing through these 2 points is given by M equals, you subtract the Y values in any order on top, that gives you the rise, and then you subtract the X coordinates in the same order, that gives you the run. I always start with the second order pair, so it's Y sub 2 minus Y sub 1 on top, and then on the bottom we have X sub 2 minus X sub 1.
Second Y minus first Y over second X minus first X. Why use this formula when we could just plot and graph? Well, like on this problem here that we're about to do, you might be thinking, I'll just draw it out and do rise over run. Yes, but if this 8 had been an 80, I don't think you'd want to be counting rise over run.
So
Okay?
this is numbers.
The numbers were real large. So that's why we have a formula for it, and math loves formulas.
8.
So find the slope of the line that goes through the given points. If push came to shove and you don't know with a formula, you could draw it out and count rise over run. But here we're going to use that formula. Did you write it down, Tim? Yeah. Okay.
Just like with the distance formula and the midpoint formula the last time, I label my X1, Y1, X2, Y2. So the first point I write down, I think of that as X1, Y1. And the second order pair I write down, I think of as X2, Y2. So here we go. M equals, we have a minus and a minus. And Y2 minus Y1. So 10 minus, what's going to go here? Okay. All over X2 minus X1. So X2 is 8 minus 2. 10 minus 1 is 9. All over 6. 9 over 6. We can cancel a 3 above and below to give us, okay, 9 divided by 3 is 3, all over. 6 divided by 3 is? So we have 3/2 as our final answer. Now, if we were to plot these points, I'm not going to bother doing it, but if we were to plot them, since that slope is positive, that says the line is going up from left to right. It's rising from left to right. So without even plotting those points, I have a good idea of what the line looks like.
This would be the bottom point. You'd be going up 9 to get to the 10, and then right 6. Okay, so 3/2. Let me punch that in so you'll be confident we have the right answer. Okay.
Any questions there? Okay. Number 7.
I think there's 3 of these. Number 7.
Same instructions. Find the slope of the line passing through the points. Here it's 4, 0 and 9, 9. Switch over. So once again, I'll label my X1, Y1 and X2, Y2.
This is not a great example because the number 9 appears twice.
Yeah, you're right.
But it's not our first example, so okay.
I'm going to let them tell me what numbers go where. Okay. Here. Okay, so 9, and here 0. Okay, here and okay, so that's what, 9/5. Can we reduce any common? Can we cancel any common factors there? No. 9/5. Leave it as 9/5.
9/5. Yesterday when we did these, I seem to recall some, they were just winding up with like 10/5, which would be 2. And students were asking, could they write it as 2/1 instead of 2? And I said, I don't think so, because it says simplified. It says type an integer or a simplified fraction. And so we typed it in, and it does not take 2/1. You've got to just type in 2. So if it turns out to be an integer, type an integer, not the fraction.
Number 8.
Oh, this is a good one.
Oh, this is a good one. Finally, a negative popping up.
Negative popping up.
-6. Okay, we want the slope of the line passing through -6, 7 and +1, 5. Switching over to my paper, I'm going to push this up. Okay.
Better write that
I'm
formula
going to.
down again,
I'm going to
since it's not
identify my X1, Y1 and X2, Y2, and I'm going to write out that formula. We ran out of paper in the other notebook we've been using, and we accidentally bought college rule paper, this notebook here, and you'll notice I just can't write on those little bitty spaces. It's hard enough on regular rule paper, but with college rule paper, forget it. I'm a big writer, and that's all there is to it. I just want to show off my beautiful penmanship. Tony, don't be jealous of my penmanship. I mean, it's that doesn't look green doesn't look good on you. Okay, I'm going to let y'all tell me. Okay, what number am I going to put here? Y2, 5 minus here.
7. Good.
Here. Okay, X2 minus. And be careful.
That minus a negative?
Well, first of all, 5 minus 7 is negative 2 all over. What happens here? Minus a negative becomes a positive. I agree, double negative. So what's my denominator? 1 plus 6 gives me a 7. And we can't really use 2/7, so negative 2/7 is my final answer.
Now, y'all see why it's a plus down here? The first minus was from the formula. The second minus was the negative 6. Minus minus becomes a plus. Any questions there? What was it? Oh, negative 2 over 7.
And I want to make up an example. Okay, I want to make up an example.
I'm sure they want.
Yeah, I know they do. Yeah, here we go. I'm making up an example, okay? Oh, I think it's a new notebook.
There's plenty of paper to waste.
Oh, you're right. Okay. I'll go back. Okay, let's find the slope of the line passing through.
So it's the same instructions as 6, 7, and 8.
And here are the points. Let's say negative 4, comma, 7 and negative 4, comma, negative 3.
Oh, we have a lot of negatives.
I know.
Good. So label the X1, Y1.
Well, it's hard to because I knew you wanted me to conserve paper, so I didn't skip a line. I'll write it right here underneath. X1, Y1, X2, and Y2. So I'm running out of room, so
You want me to do it? Because I can write smaller?
I'm going to try to write smaller. Okay. That's a negative 4, negative 3. You're right. And over here, it's a negative. The first one is negative 4, 7. So Y2, what am I going to put here? Negative 3 minus here 7. So Y2 minus Y1 here. Negative 4 minus here another negative 4. Negative 3 minus 7 gives me a negative 10.
But what's happening on the bottom?
That minus and negative becomes add. So negative 4 plus 4 gives me, not 8, be careful, negative 4 plus 4 gives you a 0. Oh
See
my.
why we're saying 0 down there? And what's going to happen here?
A number divided by 0, undefined. Correct. If we were to plot those points, we would have a vertical line passing through negative 4. Remember we said the slope of a vertical line is undefined. Now, if it were horizontal, we would have had the top 0, the bottom be a number other than 0, okay? And in that event, 0 over a number, the slope would have been 0. I wanted you to see how can you get an undefined slope for a vertical line, because the denominator becomes 0. If it's a vertical line, the x coordinates are going to have to be the same, and when you subtract a number from itself, you get 0. Any questions in our logic there? Okay.
Oh wait, you need to write a little bit about sloping.
Yeah, sure do. Maybe I'll let you do that.
Okay. We said that when we started it off today, we said a line that has x and y written in the form ax plus by equals c. That's standard form for a line, a slanted line anyway. If you have the equation solved for y, if it's in the form y equals, that's called slope-intercept form. If you have the y by itself, the coefficient of x, by that I mean the number attached to the x, that's the slope, that's why I used an m there, and the constant term over here is what's crossing the y-axis. I'm just going to say slope here, and y-intercept, well, really the y-intercept would be 0, comma, that number b.
Remember, every point on the y-axis has an x value of 0. Otherwise, it wouldn't be on the y-axis. You'd move left to right.
So, problem number 9 is going to illustrate this, and it's one of the harder problems, so don't panic. It says find the slope and the y-intercept of the line. Y equals, is that a negative 7 over 8?
Yes.
X, and then a plus 6. Ooh, no, that's not a B. Can y'all tell my B's from my 6's?
I don't know. They can't see it.
Oh,
right,
shoot.
Because I'm still showing there. That looks like a 6.
Yeah, but that sort of looks like a 6 too. That's my B, and this is a 6. The instruction said find the slope and the y-intercept. I was joking when I said this was a hard problem. Does anyone want to guess what the slope is? Negative 7 over 8. If the y is by itself, the slope is the number attached in front of x. Okay? So, negative 7 over 8 is the slope. Now, the y-intercept is an ordered pair. It's not just 6. How will I write the y-intercept? 0, comma 6. Okay, so let's see if we can type those answers in. The slope is negative 7 over 8. Now, look at how they've done this one. The y-intercept is, they've already put the 0, comma, so all you have to do is type in the 6. But this is the first problem. We're going to do another one in a moment, and I don't think they're going to have that 0 there. You're going to have to type the whole ordered pair. What about problem? Any questions? This is called slope-intercept form, where the line is solved for y. Number 10, y equals 2/5 x plus 1. This is one of those problems where sometimes students tell me, oh, I can do this without writing anything. Mr. Precella wrote all this stuff down, and I can do it just by looking at it. Well, your goal and my goal are different. What's the slope on this one?
Tony, that looks like a negative. Can you put that on?
Oh, I'm sorry. This looks like a negative here. That should be a positive 2 over 5 here. Is that the slope? And what's the y-intercept? I'm just going to say INT for intercept. It's an 0, 1. In problem 10, we're going to have to type in the 0. Well, first, slope is 2 over 5. And y-intercept, notice it doesn't already give you the 0, comma. You have to type an ordered pair, so that means put the parentheses, 0, comma, 1.
1. Oh, yeah. Where did I get 6 from?
That was the previous problem. Any questions there? Well, it's going to have to get harder. Let's see. Number 11.
I'll take over now. I just my hand
Okay.
oh, my hand was just cramping up a moment ago. So
The sign of age, Tim.
I know it. I'll see what you have to look forward to. Oh goodness.
2x plus y equals negative 1.
This little cool. It's just enough of a change in the weather to put me in a great mood. In case you can't tell.
People are watching. Used to be a lot of people from Japan watched our videos. So someone over there in Japan watching. It's nice and pleasant today in Corpus Christi. Not the usual weather. It's not really. I mean, I guess in any other part of the country, the people would be like,
It's hot.
they're insane, it's hot. But to me, it feels nice outside. I don't know what the temperature is.
Oh yeah, I know. I've been thinking about that. I mean, I've been thinking about that a lot, just because anyone that lives on the Gulf Coast would be thinking about have that on their mind. I hope
Is that a negative 1?
Hurricane. Yep,
Yes.
it's a negative 1.
switch it over.
2x plus y equals negative 1. I was going to ask him first, what's different about this problem versus the previous one? It's not in slope-intercept form. The y on number 10, see the y is by itself. Number 11, the y is by itself, so we have an extra step here.
But it's not a hard extra step. We need to get the y by itself, so what will we do? Okay.
Subtract the 2x. You
So-
need to get the y by itself.
So we have, and notice we don't have a coefficient in front of y. If we had a number in front of y, we'd have to divide also. But here, all we got to do is just move that x term over. It becomes a negative 2x minus 1. So what's the slope? Negative 2 is the slope. The y-intercept is 0, negative 1.
Oh, we finally have one where the slope is an integer. So just to demonstrate, for some reason yesterday, I guess they wanted that rise over run. Several students asked about that. Would it take it like that? And no. Okay? Although your answer is equal to the correct answer, it's not in the correct form. Be sure to read the instructions, blah, blah, blah. It says to, I guess, is there not a little thing that said, okay,
No.
okay. You're supposed to type an integer or a fraction, and I guess it didn't say that here.
No, but
So just type negative 2, and make sure you don't just type negative 1. Parentheses, 0, comma, negative 1, close parentheses.
and realize on the test you type now if you type negative 1 here in the homework, he'll come back and
And you
say you're
figure it
wrong,
out,
and you can type. Then you can correct it
careful on tests.
on tests and quizzes. You don't get that option.
Oh, also on tests and quizzes, it's not like the homework. You don't work a problem and then it tells you if it's right or wrong. Once you're finished and you click submit, that's when it'll tell you whether it's right or wrong. And then you can look at your test and review it by going through the Pearson grade book, not the Canvas grade book. Click on the Pearson grade book, find what you want to review, and click review. Okay. Any questions there? I think we have another one like it.
Oh, good.
Number 12 is a little bit messier.
Okay. 20x plus 4y equals 16. Let me write down the equation. And it's the same instructions. They want us to find the slope and the y-intercept. Okay.
Well, it's not in the... Oh, do you want to zoom in?
No.
Oh.
It's not in slope-intercept form. We need it solved for y, so there's really only one correct first step. What is it? Minus the 20x. You want to get that y term by itself, so you have a 4y equals a negative 20x plus 16.
But
Realize
y is not by itself yet.
I want it in the form y equals mx plus b, so that's why I put the mx plus b rather than putting 16 minus 20x. I put that x term first. It's still not in the desired form. We need to get rid of that 4, so what are we going to do? We're going to divide 3 by 4, and the approach I think is of just distributing through a 1/4. That's the same thing as just dividing everything by 4. It's as if you're multiplying 3 by 1/4. Basically, you're dividing every term by the 4, not just the first one. Every term gets divided by 4. 4 divided by 4 cancels out, leaving us y equals... Oh, this works out nicely. Here. Negative 5x, I agree. Plus 16 divided by 4 is 4. So what's my slope? Negative 5 is my slope. And my y-intercept?
This is the most basic type of problem solving. When we're confronted with a new type of problem, and if you know how to do one type, make it look like we're making problems 11 and 12 look like the 2 previous ones. Write them with y equals. So what was that y-intercept? 0, 4. If you look at some old math books, if you find some math books from the 70s and early 80s, the intercepts weren't defined to be ordered pairs in those books. Back when we were students, I remember the first time I ever saw a math book where you had to write that ordered pair. We used to just say the y-intercept is 4. Y-intercepts were defined, or intercepts were defined as numbers, not ordered pairs. But then someone decided, going through the 80s, that it would help students if they wrote them as ordered pairs. What it actually did was they started missing it more because they forgot to write it as ordered pairs. So the slope is negative 5. See, if we could go back to 1980 right now, what you would type there
was 4.
You would not type an ordered pair. Okay? Parentheses, but we can't go back in time. Today, intercepts are called or defined as ordered pairs.
I personally preferred it when it was just defined as the number on the x or y axis where the graph intersected.
Maybe just prefer it that way because that's how you did it when you were young. In math,
you're just being heartless today, Tony.
In math, you always, algebra especially, you do it one way, then you do it in reverse. First time in early algebra, you learned how to FOIL. Now, what do you call going backwards when you're foiling? It's another F word in algebra.
Factoring.
Okay? So you do it one way, you do it in reverse. Here we were given an equation, and we find a slope and a point. Now, we're going to be given the slope and a point, and you have to find the equation.
Oh, look at that point. Is that point a Y-intercept 4, 1. Is that the Y-intercept?
No. The
No.
Y-intercepts have to be in the form 0, comma. This is just an ordered pair. It says, find an equation of a line having the given slope of 9 and containing the given point. I would have said passing through the given point, but same thing.
Okay, so the slope is 9.
Our answer here is going to be an equation.
Line passes through.
So our answer should be y equals mx plus b.
You want to do this one, Tony?
No, I'm going to stand right here, but right now we can start typing in. Our answer is a equation in slope-intercept form. What's m? 9. So it's going to start off 9x, but we've got to figure out b.
I'll get rid of it.
Okay, so what we're trying to do, we're finding y equals mx plus b. That's going to be your answer. We already know that the m is 9. So we have y equals 9x plus b.
They didn't give us the b value, but I claim they gave us an x and y value.
See, here's an x and y, but we don't know this number b. X, y. What are we trying to hint at that we're going to do to find b? Since we have an x and a y, what do y'all think I'm trying to say we're going to do with those? I'll give you a hint. Draw some arrows.
Oh, you and those arrows.
What am I trying to say we're going to do to find b? I'm going to plug in the 4 and the 1. Plug a 4 in for the x, plug a 1 in for the y. And that should help us find b. So 1 equals 9 times x. I'm going to write parentheses 4, so 9 times 4, plus b. The 9 times 4 is a 36. What do I need to do to get the b by itself now? I want to solve for b, so what will I do?
I think they have their minds on the weekend. I hate to say it, but
Well,
someone-
then I'll just answer it for them. I'll help them out. To solve for b, you would move the 36 over by subtracting 36. So what number are we getting for b? 1 minus 36 is negative 35. So our answer is going to be this equation, y equals mx plus b. In place of the m, you put the 9. What am I going to put here in place of this plus b? I'm going to put a minus 35. So here's the answer we're going to type in. Y equals 9x, minus 35. Y equals 9x minus 35. It is. I'm putting the minus here. Okay.
plus a negative.
Plus a
is the
negative.
same as a minus.
Probably if you put plus negative 35, it would take it.
I'm sure it would.
Let's check and see.
Plus and negative is the same thing as minus, but would they take it on my math lab? Let's see. You already have the 9x. If you put the plus a negative 35,
I know in the olden days they would take it, but
Let's see.
things change. Let's see. Okay, you see they took it. Okay. And here's another one. Ooh, number 14 looks like 13. What makes it look messier? The fraction. Okay. M is a 4 over 5, and the ordered pair, let me see if I can color code all of this. 1, negative 2. So there's my M. This is just a XY. Oh, 10.
Oh, kind of sweet.
Oh, yeah. Okay, so
Now, move it up.
move it up. So M is 4 over 5. The 1, negative 2 is my XY. So we want to find Y equals MX. We know the M is 4 over 5. And we need to find B. The way we do that is by plugging a 1 in for X and a negative 2 for Y. This is going to be a little bit messier. We would have negative 2 equals, oh well, I guess, okay, 4 over 5 times 1. What's that going to be? 4 over 5 plus B. And it's a matter now of how do you want to solve this for B?
You know, you could use your equation solving skills to get rid of that fraction.
What would I need to multiply straight through by that would cancel this fraction, this denominator? Giving a hint with my pen. 5. If I multiply straight through by 5, if I do this, times 5, times 5, times 5. See, right over here, the 5s would cross cancel. So what would we have? A negative 10.
The negative 2 times 5 is a negative 10.
Equals 4. The 5s cancel, and 4 over 1 is just 4. Plus 5b.
And you know how to solve for b now. You need to get that b term by itself so you can divide by 5. So
what would I do now? I would subtract 4. Negative 10 minus 4, negative 14. Only one step left to find b. And what is it? Divide both sides by 5. So now I think we're ready to type in our answer. M is 4 over 5. B is a negative 14 over 5. So Y equals 4/5 X. Right, instead of plus B, I'm going to write minus 14 over 5. This time we'll type it in like that. So you see, you could type it in as either plus a negative or minus. I think most times they try to write answers with just one symbol, not two, plus or minus. So let's see.
Any questions there before we type in the answer?
Do y'all see how I got rid of the fraction by multiplying straight through by 5?
You could have worked with the fraction, negative 2 minus 4/5. You would have had to get a common denominator and combine the fractions. It seems from past experience, students mess up on the fractions less using this method right here.
Multiply by that denominator and get rid of it.
So type it in. Let's see. So we have a 4/5. Don't type the x in the denominator, okay? We haven't mentioned that. You need to get out of that denominator using a right arrow before you type your x, minus 14/5. Oh, you know something? Suppose maybe you think that I'm mistaken. Let's see. Let's put that x down here in the denominator. Suppose I put... You think they're going to take that? They better not. And the little hint isn't that, so they don't say, hey, you put an x in the denominator. So, get out, x Is that what I wanted to type? Yes, it is. Any questions there? Well, number 15 is the last one, so you know what I always say about the last one. It's got to be the hardest. So, let's see. Oh, wait. Huh. How does it differ? In the past, when we're writing equations of lines, there's a little measure we need to know. If you're going to write the equation of a line, you need this little measure. What measure do you need to know? Maybe that slope? So look at number 15. Look at this. Are they telling us the slope? Well, come over here. So on that one, they're giving us two ordered pairs. I think there were some other problems where they gave us two ordered pairs. Where was it? Oh. 6, 7, 8, where you had the slope formula. Yeah. What do you think we're trying to say we're going to need to do on number 15? Yeah, use that slope formula to find the slope. So let me write it down. It's two ordered pairs. 3, 4, and 9, 7. That's the thing that makes people say math is hard, the way it builds. Earlier today, you saw how to find the slope when they're given two ordered pairs on a line. Okay? Then you saw how to write the equation when you have the slope and the ordered pair. So now we're sort of putting it together. We have two ordered pairs. Well, first we're going to have to find m. Okay? First thing we need to do is find that slope. Right? And let's review the slope formula. It's second y minus first y over second x minus first x. So I need to go ahead and label the ordered pairs the way we were here. So, first x, first y, second x, second y. I'm going to so help me plug in for the y2, y1, x2, x1. y2 is 7, y1, 4, x2 is x1. So let's see, what are we getting for our slope? I'm going to write it in red. It would be a 7 minus 4. Is that a 3? And the bottom number, is that... We're not going to leave that as 3 over 6 because it can be reduced to what? 1 over 2. You can divide both of those by 3. So maybe I'm beat this to death. The way you take one problem, make it look like a problem you know how to do. We know how to do it if we have m and one ordered pair. That's what we did on problem 13 and 14. Well, now we have m. The slope is 1/2. And, well, we have two ordered pairs. I always choose the one but the number's closest to 0. And hopefully positive. Yeah. I'm going to work with 3, 4. If you want to work with 9, 7, you'll still get the same final answer. So what I've done at this point is rewritten number 15, so it looks like 13 and 14. We have m, we have an x1, y1. Okay. Let me go ahead and label that x1, y1.
That's xy.
Oh yeah, xy. I don't need an x1, y1 anymore. We only do the subscripts when you have more than one ordered pair. So we're trying to write the slope-intercept form. So we know how to start it. Y equals M. What am I going to put in place of M? X plus B. Remember what we were doing. What am I going to do now to solve for? Yeah, plug in. Put the 3 in for X and the 4 in for Y. Of course, we have to have a fraction. We have a 4 equals 1/2 times the X is 3. You might want to write that as 3 over 1 plus B. So, moving up a little. What's 1 over 2 times 3 over 1? It's going to be a 3 over 2 plus B. If you want to work at the fractions, you can just move the 3 over 2 over to solve for B. If you wanted to get rid of the fractions, what would I multiply through by? What's the denominator I need to cancel out? A 2? So we could just multiply straight through by 2 if we want. How do y'all want to do it? Multiply? Okay, so multiply. Right here it's just canceling out that 2. Don't forget to put the 2 there in front of the B. So we have 2 times 4, 8. That's a new trick.
I know.
This our little thing up here hasn't ever done any flashing, but today it is, huh? There. So do y'all see what I did? 2 times 4, 8.
Wait a minute. Did that flash? Did those projectors flash? No?
No? Oh, okay.
No. Oh. Y'all didn't notice the screens? What about over there? Did they flash? I mean, did you
No.
know?
Okay.
Oh, okay.
Okay, so the 2's canceled. Y'all see where I got the 3? Now this is not difficult to solve for B. What am I going to do to get the B by itself? I would subtract the 3, so 8 minus 3 is 5. And then, now to get the B by itself, I would divide by 2. So now we write our slope-intercept form.
What's going to go in place of that B?
Oh, well, we have a 1/2 X, that's the MX, and in place of the plus B, oh, I'm sorry. Yeah, and I'm going to go ahead and put a plus 5 over 2.
It's a positive 5 over 2, so plus 5 over 2. Generally, if B is negative, instead of writing plus and negative, you just put a minus. But my lab takes it anyway, either way.
So Y equals 1/2 X plus 5 over 2.
Get out of the denominator before you type that X plus 5 over 2. Any questions there?
Oh, yeah, okay. Let's see. Flip it over. There. Oh, let me see if I can position it. Oh, there. Oh, let me lift this up. Duh. There.
Still not showing.
I know, but there. That has the whole thing there. All right. Any questions?
Okay,
When will I see y'all again?